Hey guys, so back at it with a just quick recap, quick review of direct and inverse variation. So direct variation is when things vary directly. The relationship is also known as being proportional. Just a quick example of that is if you go to the grocery store and you don't buy anything, then you don't pay for anything. You walk into the grocery store, you walk out with nothing, so you owe nothing. But the more you buy, the more things that you get at the grocery store. So our formula for direct variation is y equals k times x. An example of non-proportional or something that would not be direct variation is y equals mx plus b. That would not work. For example, your cell phone bill, you usually have to pay a monthly fee. Whether you use your cell phone or not, you're still paying that monthly fee. Just having the phone alone, you had to pay money for it. So it was adding to the cost. That's when it's no longer proportional. So to find k, if I were going to solve this, divide both sides by x, divide by x. To get k, it's just find y over x. And that's going to come back in a second. So k equals y over x. And going back to the whole proportional thing, you don't buy anything, you don't get anything. So I would go through the origin, 0, 0. That's a key thing for direct variation is it has to go through the origin. It could be positive, it could be negative, it could be really, really steep like that, but it has to pass through the origin. So that's the key thing. It has to pass through the origin. That's because you don't buy anything. You don't get anything, 0, 0, always works out there. So that's direct variation. K is also known as the constant of variation. For example, if a pound of apples is $2 a pound, 2 would be my constant of variation. For example, if you don't walk, you're not going to go anywhere. But let's say you're walking and you're walking 3 miles an hour. Your constant variation would be 3 because that rate is 3 miles for 1 hour. So that's another thing. K is known as the constant of variation. Okay, now inverse variation, remember inverse is opposites, so it's not y equals k times x, but it's y equals k divided by x. And it's super important that you remember that the x is in the denominator. Direct, I'm multiplying by x. Inverse, I'm dividing by x. So if you were going to find k and you were going to solve it out, I would end up multiplying x and y together. So that's where people get tripped up is the key thing is the formula is what's always going to help you out. You don't have to know, like you could plug it into your formula and find k. You don't have to memorize a different formula for k. So your graph for inverse variation, it's not going to pass through the origin because you can't divide by 0. So it's not going to pass through the origin and it ends up looking like this, kind of avoiding the origin or it goes down that way. Always in kind of opposite quadrants. So then I've got this, if it's negative, doing that. But once again, you cannot have 0, so it's avoiding 0, while direct variation, you can have 0. Inverse variation is saying as one goes up, one comes down. So for example, if you have a lot of work to do, the time it's going to take you by yourself is going to be forever. But the more people that you have, it takes less time. So the more people, the less time. Well, that's never going to hit 0. You're never going to have so many people that you just get the work done in 0 seconds. It's still going to take some time to get the work done. And that's an example of inverse variation. So in an equation, if you're determining is it direct, is it inverse, is it nothing, and determine the constant of variation, I just need to see am I multiplying or dividing by the variable. Multiplying around by the variable. So on this one, see how I'm multiplying by p? So that means it's direct. Swap out colors here. And my constant of variation, so k would be -5. Notice it looks different. It's not y equals k times x. It's m equals -5 times p. But what is p being multiplied by? -5. So that'd be direct. But if I look down below, I have r equals 9 divided by d. So now I have y equals k divided by x. I'm dividing by that variable. So that would be inverse variation where my constant k is 9, because that's what's in my numerator. Now if I take a look over here, I have t divided by -4. Well, I'm not dividing by a variable. I'm dividing by the number -4, which is like saying c equals -1/4 times t. So this is still direct variation. Now my constant is just a fraction, which you're allowed to have. But I don't have a variable in the denominator, so it's not inverse. If I look at the next one, I got some work to do. So I have xy plus 3. So at a first glance, you're thinking plus 3. Well, if you subtract 3, I get xy equals -3, which looks eerily like that one. And if I get y by itself, I end up dividing by x. So I have y equals -3 divided by x, which means I'm dividing. So that would be an example of inverse, and my constant of variation, k, would be -3. Now, you might recognize this if you go back up to the top. How did you find k? It was x times y when it was inverse variation. So if you recognize it in that form, you may say, oh, k equals x times y. They just switched sides around. So this is inverse, and k is 5. Could you also do what we did up here and actually solve for y and put it in the proper form? Yes, but if you see it like that, go for it. And then taking a look at this one, I have n equals 2x plus 3. That's like saying y equals 2x plus 3. I could subtract the 3, and I'm still going to end up, I have that -3 plus 3. This is like saying, it costs $2 per hour plus a $3 fee to get in. So this would not be variation. So 90% of the time when you're adding or subtracting, it's not going to be variation. That plus 3 ruins it. But over here, the difference was that the x and y were being multiplied together. So when I subtracted 3 and end up dividing, I end up with inverse. So if you have an actual problem with it, this says if y varies directly as x, there's my clue, y equals k times x, because that's my direct variation formula. X is 10 when y is 9. I'm going to stop reading and cut this part out. I'm going to come back to it in a second, so don't fully cross it out. When x is 10, y is 9. So plug that in. Y is 9 when x is 10. And now solve for k. Well, to solve for k, I would divide both sides by 10, which means k equals 9/10. So I now have a formula for any direct variation problem related back to this, because they told you when x was 10, y is 9, which means y equals 9/10 times x. There's my rate, 9/10. Now I'm going to go back and read the second part. What is y when x is 4? So what's y when x is 4? Well, just plug in 4 for x. So what's 9/10 times 4? Remember, 9 times 4 is 36. 36 over 10 reduces to 18 over 5. And leave your answers in the proper fractions. So that's my answer. Y is 18/5. Okay, look at the next one. Find x when y is 3. So that's all I have. When x and y is 3. Not really enough. But then if I keep reading, I say, oh, if y varies inversely, and when x is 4, y is 16. That's what I'm going to use. You have to find k. You have to find your equation, the constant variation, before you can do these. So if y equals k over x, but now I know when y is 16, x is 4. So multiply both sides by 4. 16 times 4, I want to say is 64, but I don't want to make another mistake like the 2. Yeah, I'm not going crazy. So k is 64, which means my equation is going to be y equals 64 over x. So back here, the equation is what helped me get to the answer. And I'd use the equation with what I was given. Here, same thing. I have equation. I used what was given. But the problem didn't ask for the equation. It said find x when y is 3. So I'm going to plug in 3 for y and work backwards. So if I plug in 3 for y, 3 equals 64 divided by x. To undo dividing by x, multiply both sides by x, and what you end up getting is 3x equals 64. That's it. Divide both sides by 3, and if you try to actually divide it, you're going to get a decimal, which I don't want, so just leave it as x equals 64 over 3, and that's it. Okay, now in a word problem, you kind of have to read. This one, they kind of tell you. It says the cost per person to run a mountain cabin is inversely proportional. So I can just go ahead and write out my formula right now. It's inversely proportional, which means y equals k over x, to the number of people who share the rent. If the cost is $36 per person when 5 people share, what's the cost per person when 8 people share? So we don't know what the total cost of the cabin is, but the more people that go on this trip, they're splitting that cost of the cabin up between more people. So it's like if 5 people are paying for a hotel room that's $100 versus if 10 people are paying for a hotel room that's $100. Well, 100 divided by 5 is going to be more expensive than 100 divided by 10. So when one goes up, the other one goes down. That's inverse. So I know that the cost is $36 when 5 people share. Okay, so 5 people, that's going to be my x. Cost is going to be my y, because I'm not dividing the money, I'm dividing by the number of people there are. So that's why I know 5 has to go on the bottom. So 36 equals k divided by 5, because you divide by how many people are going. So I'm doing backwards to get the cost. So multiply both sides by 5, and 36 times 5, you get 180. That's my k. My constant of variation is 180. So my equation would be y equals 180 over x. What that means in the context of this problem is that this cabin costs $180. That's the fee. No matter how many people are going, they all have to pitch in and pay $180 total. So if 8 people go, 180 divided by 8, it would cost each person $22.50. Real life situation, so I don't want an improper fraction. That's it. And that's a quick recap of direct and inverse variation.